Welcome, focus learners, to today's explainer. Get ready, because we're opening up our digital notebooks to decode the absolute magic of algebra right from the ground up. If you've ever stared at a string of letters and numbers and just thought, what is going on here? You are in the exact right place. Today we're mastering linear equations step by step, pulling straight from our source material to give you a crystal clear, visual lesson. So grab some paper, get comfortable, and let's unlock these math mysteries together.
Okay, let's dive right into this. Imagine a complex steampunk contraption, kind of like a delicate balancing scale. Whenever we talk about equations, I really want you to picture exactly this machine. You see, the entire concept of an equation rests on one simple, absolutely unbreakable physical law. What happens on one side must perfectly, identically balance what happens on the other side. If you add weight to the left, you've got to add the exact same weight to the right. Otherwise, the whole machine just breaks down.
So, the crucial point here is knowing exactly what we're looking at. Take a look at the handwritten difference between an expression and an equation. On the left side, we have 3a plus 2b minus 1. That is just a mathematical expression. It's basically just a phrase. But over on the right, look at 7y minus 4 equals 17. Now that is an equation. Why? Because it actually contains an equality sign. That equals sign is literally the fulcrum of our balance machine. It's the defining feature that tells us, hey, the left side holds the exact same value as the right side.
Now, how do we actually build one of these machines from scratch? Let's translate a real-world sentence into math, piece by piece, just like we're writing it out in our notebook. Our source poses this situation. If 4 is added to 3 times a number, the result is 19. Okay, let's see a quick trick for breaking this down. First, we name the mystery. Step 1, let the unknown number be x. Step 2, 3 times the number simply becomes 3x. And for step 3, we add 4, and that word result is our big cue to write an equal sign. So we get 3x plus 4 equals 19. Just like that, we've translated English straight into algebra.
Before we actually solve these, we really need to establish our ground rules by defining two very important terms from our text, the substitution set and the solution set. You can kind of think of the substitution set as the audition pool. It's the set of all potential, maybe it'll work values for our unknown letter x. The solution set, on the other hand, those are the actual winners. That's the specific subset of values that when you plug them in, actually satisfy the equality of both sides and keep our machine perfectly balanced.
Let's see how this actually builds in a practical trial and error table. We have the equation 4x minus 2 equals 10. And our substitution set, our pool of candidates is 2, 3, and 4. Let's test them out on the left-hand side. At x equals 2, we calculate 4 times 2 minus 2, which gives us 6. Does 6 equal 10? Nope, so 2 is out. What about x equals 3? Well, 4 times 3 is 12, minus 2 is 10. 10 equals 10, yes! And just to be absolutely sure, at x equals 4, we get 14, which is definitely not 10. Therefore, only the number 3 makes it into our final solution set.
Now, what's really interesting here is that this trial and error reveals the ultimate, absolute golden rule of algebra. Because, let's face it, we can't always rely on trial and error. Sometimes the numbers are just way too big or complex. So to solve equations, we use properties of equality. We use inverse mathematical operations to isolate our unknown variable. But to keep our machine from breaking, you must swear by this one rule. What you do to one side, you absolutely must do to the other. Okay, let's put that rule to work. Watch as we step through solving 5x plus 4 equals negative 11. Imagine writing this down with me. Step 1, we want to isolate x, right? So we need to get rid of that plus 4. The inverse operation is subtraction. We subtract 4 from both sides. Now be careful here. Many students make a mistake in this step by moving the number but completely forgetting to use the opposite sign. Negative 11 minus 4 gives us step 2, 5x equals negative 15. For step 3, to undo the multiplication of 5 times x, we just divide both sides by 5. Negative 15 divided by 5 gives us our final answer, x equals negative 3. So our solution set is negative 3.
All right, time for a quick knowledge check based on a classic problem from the classwork section. If 3x equals 3, then what is the value of 4x minus 2? I'll tell you right now, this is a very common exam question. It kind of looks like a trick because there are two parts to it. So I highly encourage you to pause the explainer right here, grab some scratch paper, and see if you can balance this out yourself before we reveal the answer. Go ahead, give it a shot.
Okay, let's solve this two-part mystery together. First, we need to find the key, which is x. If 3x equals 3, we simply divide both sides by 3, giving us x equals 1. That's step 1. Now for the real magic trick.
We take that key and substitute it right into the expression they asked us about. Step 2. Insert x equals 1 into 4x minus 2. Step 3. Well, 4 times 1 is 4. 4 minus 2 equals 2. If you got 2, fantastic job. You successfully used one equation to unlock a completely different expression.
Now let's level up and apply this to the real world. Here is a geometry word problem pulled straight from the source. It says, the length of a rectangle exceeds its width by 5 meters. If its perimeter is 54 meters, find its dimensions. You see, this is where algebra becomes incredibly powerful. Once again, take a quick moment to think about how you would set up your initial variables here. Like, what exactly is x going to be?
Now, be careful here because many students make a mistake by rushing straight to the perimeter formula without properly introducing their characters first. We have to set up our variables clearly. Step 1, let the width be x. Step 2, the problem says the length exceeds the width by 5, so we write the length as x plus 5. Simple, right? Step 3, we recall our trusty perimeter formula, which is 2 times the length plus 2 times the width. Okay, now we have all our puzzle pieces ready to assemble.
And this brilliantly illustrates how the math just falls perfectly into place. Let's write out the steps together. We set up our equation, 2 times the quantity x plus 5 plus 2x equals 54. Step 2, we expand the brackets. So we get 2x plus 10 plus 2x equals 54. Step 3, we combine our like terms to get 4x plus 10 equals 54. And then, remember the golden rule? We subtract 10 from both sides. That leaves 4x equals 44. Divide by 4, and boom, x equals 11. Since x was our width is 11 meters, and our length is x plus 5, giving us 16 meters. Problem solved. You've done a phenomenal job following along today. To wrap things up, I'm leaving you with a final practice challenge pulled directly from the homework section of our source text. Number 1, if x plus 7 equals 15, what is x? Number 2, if 12 minus x equals 4, what is x? And a fun little word problem for number 3. Two natural numbers, one is 4 times the other, and their sum is 60. What are they? Use the exact same steps we practiced today. Remember, algebra isn't just about finding missing numbers, it's really about learning how to balance logic and truth in a structured way. So it makes you think, what other hidden imbalances in your life could you solve if you just learned the logic to decode them? Keep practicing, and I'll see you in the next explainer.